So this video is going to go over whether or not we are due for a geomagnetic reversal. So what do we mean when we say reversal? Essentially, our dipole planet having two poles, sometimes the field weakens and destroys itself and builds back in opposite ways. So really what this means is that north and south are not always north and south. The magnetic north can be located in the geographic south when our magnetic field is in a reversed state. And this tends to happen to the Earth in no particular schedule. And in the bottom right corner you can see how the north and south are distinguished poles, and then on the right, during a reversal, you see that, it gets kind of crazy, and it breaks down, and when it builds back, if you just flip that image on the left upside down in your mind, sometimes the south can be in the geographic north. So why does the Earth undergo reversals? Scientists theorize that when patches of molten iron start to go in the opposite direction of the molecules around them, the poles can flip within the outer core. However, this does take large amounts of time and extensive amounts of shifting within the Earth's outer core. Essentially, when this happens, the magnetic field meant to shield the planet from solar radiation and the decimatingly hot particles from the sun weakens significantly. And when it breaks down, it rebuilds, sometimes in the wrong direction, if you will, catalyzing a reversal. Since the magnetometer in the 1830s, from a study that we were provided in class, the intensity of the Earth's magnetic field tested at the surface has decreased about 10%. Generally, the field must weaken by at least 90% before a reversal ensues. So you could use that as evidence to say that we are not going to be experiencing a reversal anytime soon. However, on the contrary, paleomagnetic records also show that the intensity of the field can vary significantly with or without creating a reversal. So what trends do we see in geomagnetic reversals? There are very few reliable trends for reversals. In graphing terms, basically every data point is an outlier. Reversals do not happen in a split second, and in the amount of time it takes for us to figure out when it's happening, the reversal is probably already started or halfway over. Scientists look to rocks, like they do with a lot of other sciences that don't have a lot of good leads, and their formations, their formulation, the effect the magnetic field had on them before they hardened or crumbled, and also after. There's not a lot of data pertaining to reversal events, so we have to look other places. This is a geomagnetic reversal timescale, similar to the one we went over in class. And as you can see, there are distinguished periods where it's very frequent in the Upper Jurassic period, and then especially in the Middle Cretaceous period, there's not very many. And then in the Paleogene, it's a little more frequent, but the one that we're currently in, it seems very, very frequent. Not quite as frequent in the Jurassic area, except for in some places. But yeah, so you look at this, and I guess I would say we're due for a reversal sometime soon, but I don't think it's going to happen in our lifetime. And I think that if we did have one, it would wreak havoc on our society, especially with the technological reliance we have. But it is highly unlikely that we will experience a reversal in our lifetime. However, it is possible and likely that we are in the process of a reversal beginning to brew. So in the near future, I don't think we're due for a reversal, but near in geologic timescales may mean in the next million, which, yes, I do think that it's not going to take another billion years for us to experience another reversal based on past trends, if you will.